In part 2 of this lesson, I'll continue answering where we left off, and we left off with these two questions unanswered. Namely, in question 2 they ask, acetic acid, which has the chemical formula shown there, is the active ingredient in vinegar. Calculate the mass percent composition of only oxygen in acetic acid. So let's go ahead and figure this out. Let's start by writing out all the molar masses of these atoms that are found within one molecule, starting with oxygen, represented as O. We have a molecular mass of 16.00 AMU, and there are two oxygens, so we'll multiply this number by 2 eventually. Hydrogen has a molar mass of 1.001 AMU, and we'll multiply that by 4 because we have 3 hydrogens here and 1 here. So multiplying that by 4. And finally, carbon has an atomic mass unit of 12.01 AMU. We'll multiply that by 2, represented by the subscript 2. Now, if you multiply 16 by 2, 1.001 by 4, and 12.01 by 2 and add them all up, you should end up with approximately 60.024 AMU. And you can confirm that with your calculator. Another thing to mention is that when you add these numbers up to get 60.024, you have to keep in mind significant figures. Notice that this one had 2 numbers after the decimal, this had 3 and this one had 2. So your final answer, since you were adding them at one point, your answer should have only 2 decimal places to reflect the lowest amount. So we'll write down 60.02, disregarding that 4 AMU. Now I'll take 16.00 times 2, which was the molar mass of oxygen, and I'll divide that by 60.02, and this will give us 53.12%. Therefore, the mass percentage of only oxygen within one molecule of acetic acid is 53.12%. Moving on to question 3, they ask us to calculate the mass percent composition of sodium in sodium oxide. Sodium oxide is an ionic compound. Specifically, sodium has the symbol Na, and it has a charge of 1+. Oxygen has a charge of 2-. Now, when you bring these two atoms together, the charges will switch, leaving you with sodium 2 oxide. So I'll write that down. Na2O. Let's continue by finding now the molar mass of Na, and we know the molar mass of oxygen, so I'll write that down first. It's 16.00 AMU. Now sodium, I'll look at my periodic table. It appears to be 2.99, so Na is 2.99, and I'll multiply this number by 2. Let's use our calculator for this. We have 16.00 plus bracket 22.99 times 2. This gives me 61.98. 61.98 AMU, that's the total. And now I'll take the molar mass of 2 sodium atoms. We had 22.99 times 2 divided by 61.98, and we'll multiply this by 100%. We'll finalize with our calculator. We have 22.99 times 2, divide that by 61.98, multiply that by 100, and we end up with 74.18. 74.18% is the composition of sodium within one molecule of sodium oxide. And there you have it. That is how to calculate mass percent composition.